Now a new topic, TPI network. I am presenting a TPI network. Okay. So what is this type of network? This network is type of when you will see this type of network in any circuit, then you have to transform this type of network into this type of network. This is T, this is phi. Okay. So in what respect you will apply it? Wheatstone bridge. Because if you have a network which has 4 resistors named as P, Q, RS, and Wheatstone bridge principle is satisfied, that is P by Q equal to R by S, then here there is no current flowing through these resistors or terminal A, B, C, D, that is BD terminal, BD junction between the two terminals B and D. Okay, null condition is satisfied or balance condition is satisfied. Okay, then P by Q is to, when P by Q is to R by S, then balance condition is satisfied, so there is no current flowing through these resistors. You may connect a galvanometer in this terminal, between these two terminal, okay, to detect the current flowing through these resistors. Here current is 0, that is Ig equal to 0. Okay. Now if you have a circuit where a current flowing through this resistor, then what will be the equivalent resistance between the terminal A and C? Here there was a effective resistance, that is equivalent resistance will be, what will be the value of equivalent resistance between these two terminal A and C?
R1 R2 by R1 plus R2 means here P plus Q
are in series. That is current will flow directly through this P and Q, and
RS also
here
series.
in the lower half R and S. So P and Q, there is no branching between these two resistors. That is this same current flowing through this two resistors. So these are in series. That is series equivalent will be P plus Q, and in the lower half this will be R plus S, and these are in parallel. That is parallel equivalent circuit. How will you determine parallel equivalent circuit? P plus Q
R plus S
into R plus S by
P plus Q plus R plus S.
Very good. Okay, so it is simple. Okay, but it is harder than this. Okay, because here an infinitesimal current or a current will flow through this resistor. Okay, then you have to modify this circuit into new type of circuit with the help of this TPI network theorem or TPI network. Okay, now you have to introduce T and phi here, but you have seen here pi type of network. Okay, so you have to apply T network. So you have to apply 3 unknown resistors. You have to introduce 3 unknown resistors in this loop. So how will you apply? That is, it is A, small a, this is small b, this is small c. So
how can you determine the resistances?
How can you determine the resistance? Okay. Now you put here P, Q, R, S. Okay, so this will be you name it, any name.
G.
Denote
G.
G. Okay, G. So now you have you should calculate the value of A, B, C. A, B, C. These 3 new resistors by removing these 3 previous resistors, because you have to introduce these 3 new resistors, so you can remove these 3 resistors. Okay. Now the new modified circuit will be, this is A, this is B, and this is C, and then you have to remove it P, G and R. So I have not draw here P, G and R. Okay, actually I have removed it. Okay, because 3 new resistors I have introduced 3 new registers. That's why P, G and R are removed. Okay, so the last registers will be Q as well as S are connected as before. Okay, so this is battery. EMF E current will flow through this in this way. Okay, now you have to determine the value of A, B, C. What will be the value of A, B, C? How will you calculate this value?
Yeah.
This is a formula. I have okay. Now the formula is A equal to the product of adjacent 2 registers by sum of 3 registers.
Okay.
What I say? Product of adjacent. If you calculate the value of A, then you have to take product of these two registers, adjacent registers. Very good. P into R upon total sum of algebraical sum of 3 registers.
Oh, P plus G plus
Previous yes, P plus G plus R. Okay.
Okay.
So in this way you can calculate. Similarly, B equals to, what will be the value of B? B will be P and G divided by
Same
P plus G plus R. Very good. And similarly, C equal to, this is okay. C equal to
R plus G.
R into G, R into G, P plus G plus R. In this way you can calculate this value ABC. So ABC. Now this modified circuit is easier to you than this.
Yeah.
So these are in series, these are in parallel, these are in series, these are in series, and these two are in parallel. That is this the third modified circuit, third modified network will be B plus Q, C plus S. Now these are in parallel. So here one resistance will come from these two resistors. So this is new modified X.
Yeah.
So these are in series. So the equivalent resistance, yes, the equivalent resistance between the terminals A and B will be A plus X. So you have to calculate X. How will you calculate? You know it?
Yeah.
Okay, very good.